Today we're going to take a look at the first of four major concepts that is required in order to access calculus. This is called linear models and rates of change. The slope of a line is a really major concept that we need to understand fundamentally. We can graph a line on a set of axes, and we can label those, of course. X is the input axis and Y is the output axis. And I can label an input point x1 and it'll output to some point y1, and we can name that point x1, y1. And later on, some other input point will output to some other y location. We'll call those x2 and y2. The distance between the two x locations we'll call delta x, or x2 minus x1. The same in the y direction. Delta y will be the distance between them, or y2 minus y1. And we can note that the slope of the line will be the hypotenuse of the triangle that we generate with those two deltas. So slope, we represent usually as m, is the rise over run, or delta y over delta x, change in y over change in x. In this example slope, the first point is negative 2, 0, and the second is 3, 1. The slope is 1/5, which is a positive slope. In this example, the y locations are both outputting to 2, so this is going to be 0. In this example, the second location of y is going to be lower than the first, and so our slope is going to be -5, a negative slope. In the final example, we have the same input location, so the change in x is going to be 0, and since you can't divide by 0, that'll make this undefined. The equation of a line can be found when you have a point and the slope of a line by using the point-slope equation of a line formula. This is y minus the y-coordinate equals slope times x minus the x-coordinate. x1, y1 refers to the point on the line for which you will have numbers to fill into the formula in the following locations. The slope will also be filled in using the slope formula. Let's do an example. We're going to find the equation of the line that has a slope of 3 and passes through the point 1, -2. We'll note the slope is 3, and then we'll write down our point-slope formula. When filling in your formula, you should note that it is y minus the y-coordinate. The y-coordinate is -2, so it's going to be y minus a -2. That'll end up being y plus 2. And we'll solve for y to get our final answer. The slope of a line can be interpreted as either a ratio or a rate. If the x and y axes have the same unit of measure, the slope will have no units, and it is a ratio. If the x and y axes have different units of measure, the slope is a rate, or rate of change. Ratios are comparisons between the same type of number, and rates of change are comparisons between two different types of number. For example, I can say that 5 people out of 12 people prefer math. In this case, people, the unit, will cancel, and I'll get a direct comparison, 5 to 12. You can always tell a rate of change when the comparison is to any unit of time. Units of time include minutes, hours, seconds, years, decades, and the comparison will tell us how things are changing in time. For example, we might say that we have 13 people per 7 years. Perhaps this is an increase in population, in which case 13/7 of people per year will be our increase. In this example, we'll see how the population of Kentucky changes over the period of a decade. We'll be given the population at some initial time and at some final time. We always take final minus initial to indicate the change, and we're going to compare the change as the change in population over the change in years. In word problems, you should always keep your units so that you know when they cancel, and also so that you know what your correct units should be for your answer. In this case, I'm including people and years in the units, and I will get an answer in people per years, which is correct. Let's take a look at a ratio. This ski jump has a slope that is the ratio of its height to its length. When we fill in our ratio, we'll include our feet, our unit, so that we can see clearly that the units are going to cancel and leave us with a direct comparison, and that comparison will be 2 to 7, or 2/7. Now let's talk about graphing linear models by using the slope-intercept equation of a line. This will be the most common way that you will see equations of a line. Y equals mx plus b. M is the slope and b is the y-intercept, or the location where the line will intercept or intersect the y-axis, and that'll be at 0, b. Let's do some examples and sketch the graph of each equation. In the first example, we have an equation that is already set up in y equals mx plus b format. So when we compare it, we can see clearly that m is the same as 2's location and b is the same as 1's location. So we'll graph b at 1, and our slope will be 2 rising units to 1 running unit. In our second equation, y equals 2, we should note that there is an invisible 0x here. So our slope is 0 and our intercept is at 2. In our final equation, we should note that we are not in y equals mx plus b format yet. So first we must solve for y, and then we can directly compare it to find out what our slope is, which will be -1/3, and what our intercept is, which will be at 2 on the y-axis. Since the slope is negative, it should make sense that your line goes downwards. In order to find parallel and perpendicular lines to the following line, we'll first have to solve this so that we have y equals mx plus b format, because we're going to need the slope in order to know parallel and perpendicular lines. For parallel, you're going to have identical slopes. And for perpendicular, you're going to have negative reciprocal slopes. Once we get this equation in y equals mx plus b format, we'll denote that our slope is 2/3. And so for a line parallel, we're going to need the slope and the given point. So we'll use point slope form to fill in our quantities and find the equation of a parallel line. The simplest way to deal with this is to multiply both sides by 3 to move forward. That way, you'll just be doing a distribution on either side. And because the question wants the general form, we're going to gather all of our terms to one side, because the general form is ax plus by plus c equals 0 format. For perpendicular, we're going to start with the point-slope formula again. However, this time, our slope is going to be the negative reciprocal, which will be negative 3/2. Again, the easiest way to move forward is to start by multiplying both sides by 2. Then you'll have a distribution on either side of the equal sign. And then, since we want the general form, we'll gather everything to one side so that we're in the proper form.